All right, what's up? Today, we're going to calculate some probabilities without replacement. And I really hope you can read that or else I'm going to have to re-record this entire video. So, without replacement, that means we take stuff out and we don't put it back. So we're going to look at a lot of the same types of problems we've been working with, but now we have to take that into consideration, right? Our probabilities are going to change. We're now working with events that are not independent. Right now, we're thinking about a deck of cards, right? Originally, it's like a 4 out of 52 chance there's an ace, but if I take one out, now there's either a 4 or 3, depending on what I took out of 51 chance, right? So now we want to start to think about that. In general, some questions might tell you that things are being selected without replacement. So in this marbles example, I'm going to tell you we're selecting things without replacement, right? Because we could take them out and leave them out, or we could put them back in. Right? This could be done without replacement, take marble out, keep it out. Or it could be done with replacement. Take marble out, put it back in, right? So I would have to specify. But other situations, you just kind of have to think realistically to recognize that it's without replacement. Like for instance, if I'm picking people for a basketball team, I just have to realize that once I pick one person, I cannot pick them again. So that's going to be a scenario without replacement. So here's our context. So we've got 20 marbles in the bag, 10 of them are purple, 6 of them are black, 4 of them are brown. I know those are pretty lame colors for marbles, but my red and blue markers didn't show up as well. These are darker, so we got to go with these ugly marble colors. Or maybe not, I like purple a lot. Anyways, so question A, here we go. First question is, what's the probability? We pick 3 marbles, and all 3 are black. By the way, this is how you can structure all this in your notes, right? Pretty much just write what's on the board. Obviously, you can pause the video. That's the beauty of this thing. Pause it right now. Maybe you try to solve this before I even say anything, right? That's how we engage and like learn stuff. Learn it more if you figure out than if I just tell you. Draw some lines and words. And now that you've unpaused it, right? So here's how we approach it. It's the same way we started at the beginning. Let's use lots of lines and words. So we're going to pick 3 marbles. So I'm going to draw 3 lines. 1, 2, 3. If all 3 marbles are black, that means this one's black, and this one's black, and this one's black. If you didn't pause the video the first time, maybe you pause it now, right? Try to replace these with the correct probabilities and calculate the final answer, whatever that is, which now makes me realize I should probably have a calculator with me. So, let's do it. Probability the first marble is black. Yeah, I agree. 10 out of 20. Wait, not 10 out of 20. I lied. I don't agree with that. 6 out of 20, right? First marble. There's 6 marbles in the bag out of 20 total. We know and means multiply. And so here's where it gets a little different. If you're thinking to yourself, 6 out of 20 to the 3rd power, right? You have the right logic. But that's going to be the incorrect answer because we didn't take the without replacement into consideration. So now we have to think, if I take a black marble out and throw it across the room because we're not replacing it, we're not putting it back in, what's the probability the second marble is black? Oh yeah, that's right. 5 black marbles left out of only 19. And of course now, right, for the 3rd marble, we took out 2 blacks, so now there's only 4 blacks left out of 18 total. When we're going to go to calculate this, you got a couple options. You're going to use all 3 fractions. Make sure you're putting these in parentheses, right? Just multiply. Or one thing you might do, sometimes I find this faster to type in because I don't have to use, 6 sets of parentheses. To multiply fractions, right? We just do 6 times 5 times 4 over 20 times 19 times 18, right? And that gives us something. Let's do it. You do it, right? Like pause it. Well, I guess don't pause it. It's going to take me some time to do it. I probably should have had this done already. 6 times 5 times 4 divided by 20 times 19 times 18. It's right there. Boom. 0.018. So the probability we take out 3 marbles and all 3 are black is 0.018. Pretty low probability, right? Less than half the bag was black, so we're probably not going to take out 3 blacks, and that's what this is telling us, right? We're probably not going to pull 3 blacks in a row. All right. On to the next one. As fast as I can. All right, question B. Now we want to know, what's the probability we pick 5 marbles and none are purple? No, I lied. Don't do that. We'll do none are brown. Why would I write it in brown? None of them are brown. I don't know. It's bothering me. You could definitely pause the video and figure this out, right? So this is really similar to what we just saw in our last quiz. The only thing that's different is that we have to change these probabilities each time, right? Because we are no longer working with independent events. And now that you've unpaused it, of course, I'm sure you drew 5 lines. This one's something, and this one's something, and this one's something, and this one's something, and this one's something. Really regretting using 5 marbles. If none of them are brown, this one's not brown, and this one's not brown. This one's not brown, and this one's not brown, and this one's not brown. That's BR for brown. Now we think, all right, what's the probability the first marble is not brown? Well, there's 4 browns in the bag. That means there are 16 that are not brown out of 20. After we take one out that's not brown, that leaves 15 out of 19. Now there's only 18 marbles in the bag and 14 are not brown. And so on and so on. All right, so for this one, if I type them all separately, I got to use them. Not that like it takes that long to press the parenthesis button. I mean, let's not get crazy here, right? But so we could do 16 times 15 times 14 times 13 times 12. Why would I do 5 marbles? It would have been the same concept if I did 3 over 20 times 19 times 18 times 17 times 16, right? Like whatever that equals. Just saving time for the video. I'm not going to type that in my calculator, which might be irresponsible, but it's Friday. I thought you might need to write it down, but you could pause the video, rewind it or something. Technology is crazy. All right. As you're looking at these, hopefully you're like, oh man, these are like all the same problems we've done in the quiz conceptually, which is a good thing, because if we know how to do the quiz, these are easy for us. And if we didn't know how to do the quiz, this is more opportunity to review and get better at that stuff. Question C. Let's say, what's the probability we pick 3 and at least 1 is black? Our good old friend, at least 1. If at least 1 is black, that means 1, 2, 3. Well, that's it. 1, 2, or 3 are black, right? That's what at least 1 means. 1, 2, or 3. But I don't want to do all the work to find the probability that exactly 1's black, and then the probability that exactly 2 are black, then the probability that exactly 3 are black. That's pretty easy, black and black and black, right? But there's like 3 problems, right, that I have to add. It's not impossible. You could do it. You got to take the numbers of arrangements into consideration. It's just not the most efficient option. So from here, instead, right, at least 1 is the same thing, everything except for 0, right? At least 1 is 1, 2, or 3, just not 0 blacks. So instead of trying to find these 3 probabilities and add them, let's just find the probability that 0 are black and subtract that from 1, right? Not 0 blacks. So we're going to have 1 minus from here. Use our lines and words. This one's not black, and the second one's not black, and the third one's not black. Right? And now we go to those fractions. What's the probability the first marble's not black? Well, there's 6 blacks in the bag out of 20, so now that leaves 14 that are not. So this is 14 out of 20 times we took out one of those not blacks, so now this is 13 out of 19 times 12 out of 18. And when we do this, let's see here, 14 times 13 times 12 divided by 20 times 19 times 18, right? So that's what I'm doing, even though you can only see part of it. Oh, that's weird. My face looks close to the screen. So this chunk is 0.3193. And don't forget to subtract from 1. right? So we got to do, oh no, 1 minus 0.3193, right? I'll bring that up here. 1 minus the 0.3193 gives us 0.60, I'm sorry, 0.6807. All right. I'm like pausing like you guys are in the room here with me. It's like we're doing a video like this. So there we go. And like, turns out like we'll probably get at least one black. I think I feel okay with that. It's actually honestly a little higher than I was kind of expecting. Only 6 of them are black. So like, I don't know. I guess like, apparently they'll expect to get at least one black. Do a little geometric version of this. It's not really geometric probability because geometric probabilities only apply to independent events. These are not, but it's the same concept. The type of question, not the same concept, the same type of question. Let's look at now whatever letter we're on. D. What's the probability? Let's say we're going to pick 4 marbles, and the first brown is the 4th marble we pick. You don't need my help for that. You don't even need this video. It's like, do that. This one's not brown, and this one's not brown, and this one's not brown, and this one, unfortunately, I accidentally threw my brown marker across the room, is brown. All right. 4 browns in the bag out of 20. So the probability the first one's not brown. There are 4 browns, so there are 16 that are not brown out of 20. We took one of those not browns out, so now there's only 15 not browns out of 19. We took another not brown out, so now there's only 14 not browns out of 18. And here's where this one's a little bit different than the others. This is not 13, right? Still only 17 marbles in the bag because we took 3 out. But now we want a brown, and we haven't touched any of the brown marbles, so there are still 4 browns in the bag. And if we're going to always got to put these, well, you can think about PEMDAS and see if the parentheses matter, but for the sake of being safe, I would advise you to always use the parentheses. And let's see here. So we got 16 times 15 times 14 times 13 divided by 20 times 19 times 18 times 17, and that gives us 0.376. Erase that. Last one. After this, you guys like practicing stuff. Is this me? I don't even know. I have all the questions on the smartboard over there, but I'm like making them up anyway. Let's say we're going to pick 3. What's the probability? They're all the same color. Ooh. So now we got to think about this. I really want the brown marker. If they're all the same color, this is going to take some work, right? It's going to take some time because this means 3 possible things, right? This means they're all purple. This means, or I'm sorry, this doesn't end. This means they're either all purple or they're all black or they're all brown. Right? All the same color means they're either all purple, all black, or all brown. So we're going to have to really treat this as 3 separate problems. Find the probability they're all purple plus the probability they're all black plus probability they're all brown. I should have definitely told you to pause the video right after the question without me saying all that stuff. If you could go back in time, do that. From here, you got this. Let's see. All right. Purple and purple and purple. 10 purples out of 20 times 9 left out of 19 times 8 left out of 18. All black. 6 blacks out of 20 to start. So this is black and black and black. 6 out of 20. Now there's only 5 blacks out of 19 and 4 blacks out of 18. All brown. Man, if these colors don't show up in the video, you can't read this. It's like a massive waste of time. All brown, 4 browns out of 20, 5 browns out of 9. What am I doing? I'm looking over there. 4 browns out of 20, 3 browns out of 19, 2 browns out of 18. All right. This time to save time, just different thing with the calculator, right? 20 times 19 times 18, right? That's 6840. So for all of these, the denominator is going to be 6840. And I can do this in my head, right? 72 times 10 is 720. Over here, this is going to be out of 6840. 6 times 5 is 30. Times 4 is 120. And then over here, out of 6840, 4 times 3 is 12, times 2 is 24. Right? Like, you don't have to do that, right? You can multiply all the fractions, but for me, I felt like that was faster, right? So like 720 out of 6840 comes out to be 0.1052 plus 120 out of 6840 is 0.0175, and 24 out of 6840 is 0.0035. All right, so now I have to add these 3 things. And when I do that, let's see what happens. 0.1052 plus 0.0175 plus 0.0035. All right, that seemed unnecessary. And that's it. So let's see here. What do I have on the actual? When I actually prepared this, I think you could stop now, but I'm going to throw on a couple others that'll help us review some of the ideas on the quiz. So, right, you choose if you keep watching this video or not. If you had any hesitation on the quiz, probably a good idea to keep watching, because these are the same types of ideas. Notes-wise, you could stop now. Or keep going. You know what works for you. Letter F. Pick 3. Let's look at the probability. They're all not black. Right? This is the same thing as 0 blacks. Right? So not black and not black and not black. I'm going to stop there. You don't need me to do that for you. You got that. Not black, not black, not black. I'll just write down the final answer. You figure out where it came from. That's like kind of pointless in a video, right? I didn't actually teach anything. But the reason I bring up this problem is I want to look at this, right? All not black, that's 0 blacks. I feel like we might have done a question like that already. Let's look at how that compares to something like letter G here. We'll add, pick 3 marbles. What's the probability they're not all black, right? So just by flipping these words, that makes a major difference, right? And we've seen this obviously, but now we're looking at it without replacement. So here, up top, right? This all not black. That's 0 blacks. But not all black marbles, right? That just means not all of them, right? So you could have 0 black marbles or 1 black marble or 2 black marbles, right? That's what not all means. Just literally everything except all 3 are black, right? So just literally not all 3 are black. So similar to the at least one problem, we could find the probability that 0 are black, find the probability exactly 1 is black, find the probability exactly 2 is black, and then add those 3 answers. It's just not the most efficient option. We know how to do this. In the next problem, before I end this video, I'll do these kinds of things. But instead, a more efficient option, right? We want everything except for 0, 1, or 2 blacks, right? We want not all 3 are black. So instead, we'll just do 1 minus the probability that all 3 are black, right? Which is going to be 1 minus black and black and black. 6 out of 20 times 5 out of 19 times 4 out of 18. Really wish I saved that number from the all are the same color example. So we're going to have what? 20. So like if I, right, this whole chunk in here comes out to be 120 over 6840. So if I just kind of go over here because I'm out of room. So we have 1 minus 120 over 6840 is 1 minus, right, this is 120 over 6840 as a decimal is 0.0175. Right, and we subtract that 1, we get 0.9825. Soak that in. So, super likely they're not all black. That shouldn't surprise us because there's only 6 blacks out of 20. It's 50-50 chance it's purple. Like if I take 3 out, I'm probably not going to get all blacks. That's what that's telling me. Last one. Oh my God, my arms are tired. Hope everybody's having a good day. Whether you're one of my students or some rando watching this video, hope you're having a great time. Thanks for watching my video. Last question. Who knows what letter we're on? I'll call it Z. Pick 3. What's the probability? Exactly 1 is brown. I'm like sweating this video. This is intense. So, draw some lines and words. Why would I win pen and purple? Maybe we do something like this. Brown and not brown and not brown, right? This is a situation where exactly one of them is brown. So this is going to be, let's see, there's 4 browns out of 20 times. Now the second marble is not brown. The one I took out was brown. So there's still 16 that are not brown, right? The 10 purples and 6 black. I didn't touch any of those. But only 19 marbles now. And here I took one of the 16 that was not brown. So now there's only 15. So this, let's see here. 4 times 16 times 15 divided by 20 times 19. You'd think I'd remember that denominator by now. Times 18. So we got 0.1404. So this is 0.1404. But hopefully you're thinking that's not the final answer. Because sure, this is one way we could get exactly 1 brown, but it's not the only way. The 1 brown doesn't have to be first. We could also have not brown, and then the middle one's brown, and then the next one's not brown. Now, if we write our fractions out here, the probability of the first one's not brown, right? 10 and 6, there are 16 that are not brown out of 20, times the probability the second one is brown. We haven't touched any of the browns, so there's still 4 browns out of 19, times. Now we're taking out a not brown. We took one of the not browns out, so now there's only 15 not browns out of 18. Now, when we multiply here, even though it's in a different order, right? Multiplication order doesn't matter. 2 times 3 times 4 is the same as 4 times 2 times 3. So we're still multiplying a 16, 15, and 4 on the top. 16, 15, 4. We're still multiplying a 20, 19, 18 in the denominators. So this is also going to be 0.1404. Of course, lastly, the 1 brown could be first, it could be second, or it could be third. So now we've got not brown and brown. 16 out of 20 are not brown times 15 out of 20. I'm sorry, 15 out of 19 are not brown, right? We took 1 not brown out, so only 15 left are not brown, 19 left total. We haven't touched any of the browns, so there's still 4, but only 18 marbles. And again, we're multiplying the same numbers in our numerator, 16, 15, and 4, and the denominator. So this is also going to be 0.1404. So we could do these 3 scenarios out separately. The 1 brown could be first, or the 1 brown could be in the middle, or the 1 brown could be third. So we could add these 3 things, or to save a little time, we could just take this 0.1404 that we started with, and we could just multiply it by 3 because there are 3 different arrangements. So even though we have the without replacement, we can still safely multiply by that number of arrangements. Even though the fractions are changing, we can now see that the denominators and numerators, collectively, we're multiplying the same trio of numbers in this example. So I think that's enough for today. Have a wonderful, glorious afternoon, and I'll catch you in the next video.